Imagine talking to a machine that can answer your questions, write code, create images, and even help you study. Sounds incredible, right? But here's a question. Can a machine actually think like a human? That's exactly what artificial intelligence all about. In today's video, we are going to explore what AI really is, where it came from, and why it has become one of the most important technologies of the 21st century. Let's dive in. To understand artificial intelligence, we first need to understand what intelligence is. Intelligence is the ability to learn from experience, solve problems, understand information, make decisions, recognize patterns, adapt to new situations. Humans naturally have these abilities. AI aims to give computers some of these abilities. According to Alan Turing, AI is a machine exhibits intelligent behavior equivalent to or indistinguishable from that of a human. This means if a computer behaves like a human, thinks like a human, solves problems like a human, answers questions like a human, then it can be considered intelligent. For an example, if you chat with ChatGPT without knowing it's a computer and you think you are chatting with a person, that reflects the idea behind Turing's definition. Who was Alan Turing? He is a British mathematician. Also, he is computer scientist. He is considered the father of computer science and he proposed the famous Turing test. What is the Turing test? Imagine a person chats with two participants. One is human and another one is a computer or machine, right? If the judge cannot reliably tell which one is the computer demonstrates human like conversational behavior. According to John McCarthy, AI is the science and engineering of making intelligent machines. Let's explain this. Science means understanding how intelligence works. Engineering means building systems that can perform intelligent tasks. So, AI is about studying intelligence and creating machines that can use it. Who was John McCarthy? He is an American computer scientist and coined the term artificial intelligence in 1956. One of the founders of the AI research field. We can simply say artificial intelligence is the simulation of human intelligence processes by computer systems. Artificial means created by humans. What are the examples? Computers, robots, and softwares, etc. Intelligence means the ability to learn, think, reason, solve problems, and understand. Simulation means imitating an mimicking something. It behaves similarly without necessarily working the same way. For an example, a flight simulator imitates flying without being a real aircraft. Similarly, AI simulates certain aspects of human intelligence. What can AI do? AI systems can perform tasks such as learning from data, recognizing faces, understanding in speech, translating languages, answering questions, detecting spam, recommending videos. What AI can't do? This is important because many beginners have misconceptions. AI does not have human emotions, truly understand everything like a person, have consciousness, know everything. Instead, AI uses algorithms and data to perform specific tasks. How many times did you use AI today? Examples: unlocking your phone with Face ID, YouTube recommendations, Gmail spam filtering, Google Maps route suggestions, ChatGPT, voice assistants. The next topic is use cases of AI that often go unnoticed. The first one, spam detection. What is spam? Spam refers to unwanted or unsolicited messages, usually sent in bulk. These messages often include advertising, fake promotions, phishing emails, scams, malware links. For an example, suppose you receive an email saying, "Congratulations, you won $1 million. Click here to claim your prize." This is a common example of spam or phishing. What is spam detection? Spam detection is the process of automatically identifying unwanted emails or messages and separating them from legitimate ones using AI. Instead of checking every email manually, AI analyzes each incoming message and predicts whether it is spam or not spam. How does AI detect spam? AI learns from large collections of previously labeled emails. It looks for patterns such as suspicious words such as free, winner, congratulations. The next one, unknown or suspicious email addresses. The next one, too many links. The next point, dangerous attachments, repeated messages, abnormal sending behavior. Over time, the AI improves its accuracy by learning from new examples. What are the real world examples? AI powered spam detection is used in Gmail, Outlook, Yahoo Mail. Whenever a suspicious email arrives, AI automatically moves it to the spam folder. The next topic is recommendation system. What is a recommendation system? A recommendation system is an AI application that suggests products, movies, songs, videos, or other content based on a user's interests and behavior. Instead of showing the same content to everyone, AI personalizes recommendations for each user. How does it work? AI analyzes information such as videos you watched, products you have purchased, songs you listened to, search history, items you liked or rated, time spent viewing content. Using the information, AI predicts what you are most likely to enjoy next. What are the everyday examples? First one, YouTube. If you watch programming tutorials, YouTube starts recommending Java tutorials, Python courses, AI videos instead of cooking or sports video. The next one is Netflix. If you watch action movies, Netflix recommends more action films instead of romantic comedies. The next one is Spotify. If you often listen to pop music, Spotify suggests similar artists and playlists. The next one is Amazon. If you buy a laptop, Amazon may recommend laptop bags, wireless mouse, keyboard, USB hub. The next one is TikTok. TikTok quickly learns what types of video you watch and fills your For You page with similar content. Why recommendation systems matter? They help users to discover content they might enjoy, save time searching, get a more personalized experience. They also help businesses by increasing user engagement and sales. Our first challenge is try to color this map using four colors. We can use red, green, blue, and yellow, right? Whether the neighboring provinces do not share the same color, right? This is the northern province. We can use red color for this, right? But can you color these provinces from red? No, you can't. You can color these also, and central can be red, right? You can't color these things from red, right? I use green to color Western province. You can't color these provinces from green, right? But you can color these. And you can't color these things from gray, right? So I use another color, blue. I use it for these. You can color these two things and you can color this, right? Then sorry, I got yellow color to color these things, right? Now our requirement is satisfied. See, neighboring provinces do not share the same color, right? See, different colors, right? Okay, try this on your own. What does AI thinks mean? When we say AI thinks, we don't mean it has a human brain or emotions. AI doesn't have feelings or consciousness. Instead, AI processes information, follows rules, and makes decisions based on the data it receives. Think of AI as a decision making system. It receives information, analyzes it, makes a decision, and performs an action. Human thinking versus AI thinking. Imagine you are crossing the road. Your brain asks questions like: is a vehicle coming? Is the traffic light green? Is it safe? Then you decide walk or wait. Humans may. Let's imagine we are creating an AI to play the classic pun game. The ball moves up and down. The pedal must follow the ball. The objective is to hit the ball back. How does the computer know whether to move the pedal up or down? Step 1. AI first observes the environment. Is the ball moving upward? The computer checks the ball's movement. This is the input. The next step. Now AI decides. If the answer is yes, move the pedal up. If the answer is no, move the pedal down. Notice that the AI isn't guessing. It follows a logical rule based on the information it receives. Once the decision is made, AI performs an action. We can represent it like this. According to our scenario, we can represent it like this, right? A decision tree is a flowchart-like structure that helps AI make decisions. Each question is called a decision node. This is a decision node, and each answer becomes a branch. And the final action is called a leaf node. These are the leaf nodes, right? This is a decision tree, right? This is the pseudocode for the decision tree. Pseudocode is not a programming language. It is a simple way of writing the logic of a program using plain English. Programmers use pseudocode to plan algorithms before writing actual code. This code does exactly what the decision tree shows. It checks the ball's direction and performs the appropriate action. Let's see real world examples. AI uses similar decision making in many applications. First one, self driving cars. The question is there a pedestrian? If it is yes, the car should stop. If it is not, keep driving. The next example, face recognition. Does the face match the stored data? If it is yes, unlock phone. If it is not, keep phone locked. The next one is spam detection. Does this email look suspicious? If it is yes, move to spam. If it is no, move the inbox. Move to inbox. The next one is chatbot. What is the user's question? It chooses the most relevant response. Imagine you are creating a computer program to play a game. You might think, I'll just tell the computer what to do every situation. Sorry, what to do in every situation. Sounds simple, right? But what if there are millions or even billions of possible situations? Can we still write a rule for every single one? That's exactly why we need innovative AI. In traditional programming, developers write explicit instructions for every situation. This is an example. This approach works well when the number of possible situations is small and predictable. Mm, what if there are thousands, millions, or even billions of possible situations? Writing a separate rule for every possible situation becomes impossible. This is where traditional programming reaches its limits. For an example, tic-tac-toe. Tic-tac-toe is a simple game with only a 3 by 3 board. Most people think it's easy. However, there are approximately 255, 168 possible games that can be played. Can a programmer manually write rules for 255, 168 possibilities? No, it would take for too much time and would be difficult to maintain. Second one, chess. Now move to chess. Chess is much more complex than tic-tac-toe. According to your sorry, according to our lecture, after only the first 4 moves, there can be about 85 billion possible game positions. Can anyone write 85 billion different rules? Obviously not. Even modern computers cannot rely on manually written rules for every possible position. Look at these things. As problems become more complex, the number of possible situations grow rapidly. This is called a combinational explosion. The number of possible it's not combinational explosion, right? It should be combinatorial explosion. So, why do we need AI? Instead of writing billions of rules, we teach computers how to learn, pattern, and make intelligent decisions. AI learns from data, experience, patterns. Instead of one rule, another rule, thousands of manual rules. What are the real life examples? First one, Google Maps. Imagine writing a rule for every possible route in the world. Impossible. Instead, AI analyzes traffic and recommends a good route based on current conditions. The next on YouTube. Can Google manually decide which video to recommend to every user? No. Instead, AI learns from your viewing behavior and recommends videos you are likely to enjoy. The next one, self-driving cars. Imagine writing instructions for every pedestrian, every traffic jam, every cyclist, every road condition. That would be impossible. Instead, AI learns to recognize situations and make decisions in real time. What about ChatGPT? If developers had to manually write an answer for every possible question, it would never be enough. Instead, large language models are trained on vast amounts of text to generate responses to new questions, right? Okay. Find out difference between traditional programming and artificial intelligence on your own, right? That's all for today's lesson. I hope you now have a clear understanding of the fundamentals of artificial intelligence and why AI plays such an important role in solving complex problems. If you enjoyed this video, please give it a thumbs up, subscribe to the channel, and turn on the notification bell so you never miss our upcoming AI lessons. Thanks for watching, and I'll see you in the next video.